You know the drill by now, just waiting for Twitch to catch up. There we go. I should be live. Hello everyone, welcome back to the Advent of Code. I only have one day to do today because I'm up to date otherwise. And I have some ideas for how to approach it. And if I finish early, then I'll do the same thing as yesterday and I'll move back to working on the compiler. I don't have anything else to mention, I believe. I haven't done anything like doing type level stuff or brainfuck in between streams. I've done some work off stream on the compiler, but I'll get back to that when we switch after doing the Advent of Code. So, let's go. Day 5 is going to be interesting because it's about ranges and testing properties of ranges. That's a kind of problem that shows up quite often in the Advent of Code, and I don't have anything in my library for this. And I think I want to spend the time this evening to not just solve this particular problem, but write library code for the future to handle ranges moving forward. So let me do quickly some setup. I will want to first download the input. This is day 5, isn't it? We can have a look at the input, see what it looks like. Okay, those are big ranges. Yet again, not a day I'll be doing in Brainfuck, I believe. And I will want to start not directly with the code of that day, but I will want to start instead by doing a small library for sets of ranges. What I will want to have is, and I'm just going to call that range set, I suppose. I will want to have a type, which is a range set for values of type A, whatever that is, which is actually a new type. A range set is just a set of ranges of A. Using the idea here is I'm going to be using the normal set type, which is implemented under the hood as a tree, as a binary tree, which has the nice property of values are kind of sorted by default within, which means we can do such as give me the first value in ascending order that doesn't match a predicate or that matches a predicate, which means we can, by hiding the implementation detail, maintain a tree of ranges that are sorted, and we can do stuff like checking membership within a range by iterating much faster. So that's going to be the idea. Hello, how are you? So here a range of values is going to be just a range of 2 values. But crucially, I think I will want to not export this constructor out of this file. Let me just range. Do I want to make those lenses? Probably not. Because here there's an underlying assumption that end is greater than begin, which if someone uses the basic constructor of that type, that assumption is not checked. We want to show equality and ORD, I believe, because the default ORD is perfectly fine. So a common approach to that problem, where creating a value might break some of the invariance around it, is to not export the constructor out of the module. So here we would only export range, but not its constructor, and instead provide functions such as range, a function that takes a value of type a value of type A, and returns a range of A, but instead make it return a maybe of the range, and make it guarantee that, okay, it only returns the range if the invariant is respected. We could also consider offering some other functions for this small library, which is, okay, sometimes you really want to like guarantee, like give two values and create a range and bypass that check, there's two possible things here. That would be either we ignore the check and we let the user create a range using a function that will not check the invariant and everything might break down the line, or we could also expose a function that panics if the invariant isn't met. And I think since this is intended to be a library, I would prefer not having a panic in this and let the user use this function in terms of maybe and panic if it doesn't give a range. But we could, I suppose, provide a range unsafe, which I hope by its name is clear enough, like, oh, you should probably not use this if you don't know what you're doing, which is in fact just the range constructor unchecked. Okay, so now we have a notion of range, something that has a beginning and an end, and that's about it. And we have our set of ranges. There again, the range set is going to be exported out of this module, but the constructor will not. We will not let people see that the implementation detail is within is a set of ranges. So we'll have to provide a bunch of functions around this to allow usage of this type without leaking the actual implementation detail. What we will want will be to provide a classic empty function, which is a range set of A, and empty is just range set of set empty. I'm going to import this thing qualified as S. There we go. Actually, do I want to do probably a deriving show? Do I want to make equal and OR on this? It probably doesn't hurt, even though it's kind of not really required. I can do that. Now the trick is going to be checking membership. So I will want to check member, which is, and I'm going to look at how set implements it in terms of like trying to copy the API of set. I suppose I could do singleton as well. So singleton will be taking a range of A and returning a range set of A, and singleton will be simply range set of singleton. From list is something we're going to want to do at some point, but I will write it in terms of insert, so insert will have to come first. Delete, I think I'm not going to do yet. Member is the value first, then the set. Okay. Do I want to... Yeah, I'm going to call it member just because most containers use that term. I think within would be a better term for ranges, but maybe I'm going to call it within. Because it's not a member of the set. It is of the range set. It's within the ranges in the set. So I have some value A. I have a range set of A. And I will want to return a Boolean value that tells me whether that value is in the thing. And the upside of having within the argument here, I can do X within a range set S. And that function is going to be, so what I'm going to want to do is look up the largest element smaller or equal to the given one, except this would be with a range. So I will want to find... I guess I could do this with a create a fake range for this. Or perhaps instead I should do some kind of take while or filter or something like this. Now I think it's easier to do a lookup LE or something like this. So I want to find the largest element smaller or equal to the given one. So that would be lookup less or equal of a range that contains that only that value X within the set. And that gives me maybe a value. So I guess I could do this in the, so from maybe false, largest candidate would be this. Since this is now a do block in maybe, if this fails to give me a maybe value, this returns nothing, and from maybe will give me false. Now I have here something. Why do I have range set again after the equal sign? This is the name of the constructor. So that's the name of the type, and that's the name of its constructor. Unless you mean something else and I've messed up somewhere. Like a type declaration is like the name of the type and then its constructors. And when you have a type that has only one constructor, especially if it's a struct, for instance, it is customary to have the name of the constructor being the same name as the type. A convention you will see almost everywhere. And here is the same. This type range set has one constructor range set. Yeah, an example of this would be the Boolean type, which has two constructors, true and false, neither of which is named Boolean. But yeah, I could absolutely call this the RS constructor if I wanted, but it is customary if there's only one constructor to a type to give it the same name. Okay, so now I have here the greatest range whose beginning value is less or equal to x. So I know for a fact that the beginning of this range is less or equal to my current value x. So the only thing I need to know is, actually, I probably don't need this from maybe. That's probably overkill. I can probably instead do a case of this of nothing. This function returns false, just a candidate, so just a range. That's gonna conflict. So just R a range. And now I know that the beginning of this range is less or equal to x. X will be within the range set if the end of the range is greater or equal to x. So this would be the range end of R is greater or equal to x. Or I suppose I could write this as x being. That feels better. Okay, so now we have a set of ranges, and we are gonna assume, and the idea behind the range set is the sets are disjoint. There is no overlap within the sets in a range, which will have to be enforced at construction time. So now we can test whether a value falls within one of the ranges of the set, and we don't have to iterate over all of the ranges. This thing is only log n. I think it is log n. It is log n. So that's a lot more efficient than iterating over a bunch of different values. And now I think the only thing that we need would be, well, we only need to actually get started with this, would be insert a function that takes a range A, a range set of A, and returns a new range set of A in which this range has been inserted. And here is where we're gonna check the invariant, as in we're gonna make sure that if this range overlaps with any existing range, we'll merge it. So I'm inserting a new range in a range set S. What do we do here? So we go back to our functions on the set. The ones I'm interested in are those, this one, span specifically. So it's gonna assume that the sets are like the values are sorted and the predicate only applies to some values, and it's gonna give me, given a predicate and a set of values, two sets. The sets of values that match the predicate and then the rest of the values, assuming that after that they will no longer match the predicate. So I can get all of the sets that do not contain my new set, do not overlap with my new set because they're below it, then take this second set, redo a span to then split it in two to get all of the ranges that are greater than my new set, and I'll have 3 lists of sets, all of the ranges below, all the ranges above, and the ones that overlap. So if I do that, I'll have below and remaining, which are going to be 2 lists of sets, or 2 sets, I suppose, rather, which is going to be this span antitone thing. That is going to be matching a predicate on my set here. And what I will want to remove everything that's below, and something is below if the end of that range is strictly less than the start of my new range. So if that is true, it ends up here in the sets that are below, and we get a second set, which is all of the ranges that do not match these predicates, the ones that overlap, if any, and the ones above. We can split remaining into overlap and above by doing the exact same function. And here we will want... I will want to keep all the ones that overlap first. So this function here should give me the ones that overlap. And that would be that the beginning of that range is less or equal... Oh, no. Let's start begin. Is less or equal to the end of my new range. So now I should get the, and I do this on the remaining ones. So now at this point I should have 3 sets: ranges below, ranges that overlap, ranges that are above. Now, this could be an empty set, is the thing. Because the idea is now I can replace all of the ranges within that set, regardless of how many they are, by one range, which is the overlap of this one and the new one. So what I'm going to need to do is basically find the minimum begin value within overlap, find the maximum end value in overlap, compare that with these ones, and create a new range that has like the minimum of the minimums and the maximum of the maximums, and then recreate a set by recombining everything. So, do I have... Is there like a minimum and maximum? There is. I suppose since there's a lookup min that gives me a maybe and a lookup max that gives me a value, I assume the find min that gives me a... yeah, okay. So the find one panics in the case where there's no element. So I want to do a lookup. So new overlap begin is going to be, I do a lookup of the minimum value of the overlap, which will be the lagging behind. As in, I don't know how much delay there is on Twitch. Let me know, let me know when you hear this, basically, and I'll see how much that is, back and forth. So I'll get the minimum range of the overlap, which should, since I have the guarantee that all the things are disjoint, should give me the minimum value. That's a maybe value. I can do then a maybe on it, and I can provide a default value if there's nothing, a function to apply on the a value if there is one. If there is no minimum range because there's no... Oh, sorry. Please do ask questions if there's anything that's unclear. I'm perfectly happy to like draw ASCII art and explain more things. But here the idea is those are the ranges that overlap. So here I do a lookup min of the overlap that gives me a maybe range, which would be the smallest range in this set. But if there is no set in the overlap, then my minimum value will be the one from the new range. So that would be range begin of the new range. And if there is one, then I want to... How do I want to do this, actually? I might want to do this differently. Because here I want to apply basically range begin and get the minimum. So this would give me the minimum value of the range if there is one. And otherwise give me the beginning of the range. But maybe I want to do instead... Let me think about it. There's like, I know how to write this. The question is how to write it in a way that's elegant, is the question. Because basically I have two cases where this value appears. Either this did not give me a value. Lookup LE, does range have an order? Yes, ranges are ordered. I've derived the stock implementation of ord, so it will sort it by the beginning value first and the end value second. So if two ranges have the same beginning value, the one that has lower end will be considered first. However, an invariant of this type, which will be enforced by the fact that the only API function that we will provide is insert, and it guarantees this invariant, is that the ranges within the set are all disjoint. Therefore, there's never overlap between two ranges in my set. So now this lookup LE here will give me the greatest range that is who's less or equal to this one. Since this range has twice the same value, this will basically be the greatest range whose start value is less or equal to this value x. So for instance, if my value x is 4, a range from 3 to 5 would be probably the one that has the if it's disjoint, the start value that's the lowest below, the greatest below x, and then if that's I get this a range like this whose start value is the greatest I have below x, I only have to check that x is less than the end, and that tells me whether it belongs to this particular range, and if it doesn't, since I have this invariant that my range set is all these disjointed ranges, if it's not the case, then it's not part of this specific range, therefore it's not part of any range in the set, and therefore it's not within this range set at all. Now the trick is here, I need to guarantee that when I insert a new range, I perform all of the fusion required to maintain this invariant that there is no overlap between the ranges, that all of the ranges are disjoint. And I'm just trying to figure out how to do this in an elegant way. Actually, I'm gonna break this into a range which is new beginning, new end. That way here I can just use NB NE. And here, this makes it a bit more. So I'll do a lookup min of the overlap. So for all the ranges that overlap with my new one, I'll get the minimum of them if there is one. If there is one, I apply the range begin function to get the lowest of the ranges to get the lower bound of the overlap. And otherwise, if there isn't one, I use this NB value. But here, however, I need to do a min NB as well. Yeah, the thing is, like, if you don't merge the... I don't know what part 2 is about, but I suspect part 2 will be about modifying the ranges and therefore making it more complicated to perform like membership checks. And if you can merge the ranges, then you end up with like membership tests that are a lot easier to write and like a lot more performant to perform. So this would be, if there is a value here, I still want the minimum between the new range and the minimum of the overlap. I do the same thing for the end of the overlap. And now, with all of this, I have the one range that combines everything that we have seen, which means I should be able to create my new range set. And let me see quickly. This would be, I have a range and 2 existing sets. I can probably do, is there a unions? There is a unions. So let's use that. This is a unions of sets. I can actually rewrite this purely with the... This is the set of the ranges below. Union the set of the... a set which is just one range, which is... so range overlap begin overlap end, and the set of values above, and all of this is wrapped back into a range set. Okay, let's try to compile this first, and then let's test it. What's wrong? Oh, yes, of course. Here I'm calling singleton, which is this one here. I meant to call the S1 from set. Okay. Here I forgot to mention order of A in the constraint, which will be basically everywhere. Like here I will need order of A as well. And I will need order of A as well here. Okay. So I did not export the stuff here, so empty needs to be exported. Yes, okay, I'll go about it in a second. I'm just gonna finish this, and I'll go about on it in a second. We're gonna actually, I'm gonna put some statements to actually debug it and make sure that it works as expected. So up and insert. Perfect, which means now I can open it in GHCI. Let me actually do this in a term window. I'm gonna zoom a tiny bit, and I'm gonna put here so that's still visible and the code is still visible. And the size of the font should be fine. Stack GHCI. Okay, so if I import AOC range set, there we go, I have it in my scope. So let's let's rewrite the insert logic manually to have a look. So let's imagine I already have, oh, I should make one more function before that. I should make from list that takes a list of ranges of A and returns a range set of A. And from list is simply a fold L prime. So we fold over this range using a strict accumulator. The function we use for our fold is insert. The basic accumulator is actually it's going to be flip insert, I believe, but that's fine. Is going to be empty, the empty range set, and that's it. That should be it. And I forgot, of course, to say that this is ORD. And I need to export this out of this module. Okay. Good, so I can go back here. So let's imagine I'm gonna make a R function which is gonna be from just of range. For convenience, import data maybe. Ah, come on. Wait, where is... I don't have... Oh, it's in the prelude. It's in the prelude. Oh, come on. Okay, I'm gonna write it manually. This is from just of range RE. What is happening? There we go. I can't type. So I have this small function that creates a range without actually checking it. So I can do R12 and it will give me a range begin, range end. There we go. So let's make a range set S, which is a range set of int, and it's going to be made by using from list, and this list will contain the range. Let's put 4 of them. This will contain the range 1, 5, the range 10, 15, the range 20, 25, and the range 30, 35, let's say. Which is, of course, a range set from list. Oh, I thought I had imported it. Maybe I haven't. Okay, so let's do that again. What are you unhappy about? Type of R is given 2 values. Oh, here I didn't type the R. There we go. Sorry for all of the error messages we've given the way the project is structured. That's not great, but that's how it is. So I called it S. Why didn't it work? Why didn't that work? Seems to have worked. GHC, what's happening to you? Okay. So I'm gonna just make sure. There we go. That's an int. So this range set, this set of ranges of values contains the range 1 to 5, the range 10 to 15, 20 to 25, 30 to 35. Let's go over what the insert does. So let's say I'm trying to insert the range 20, let's say 14 to 26. So so the new range is going to be the range 14 to 26, let's say. So first I get import data set qualified as S. I'll do this thing. And here, so NB is not in scope. I've called it new range. I'm gonna call it, so this is gonna be, so I'm gonna use the same notation I've used. So this is gonna be NB and NE. Oops, not what I meant to do. So now we have the same names of variables. We have the range set S. We have NB, the new beginning. Oh, come on. Why are you so weird today, GHCI? What's happening? Okay. So we have our range set S here. And actually, I'm going to say that S prime is... I probably want to get the actual set within this, and I don't have a way to get it from this. How do I get it? I'm just going to do this instead. I'm going to copy this. So S equals that. And that's a... GHCI is annoying today, and I don't know why it's doing this. I guess the constructor isn't in scope. That makes sense. Okay, let me recreate S as not being this from list, but the set from list. So the set of range of int, so that's my variables. There we go. So this S now is the same as this S here. It is a set of ranges. NB is the new value I'm trying to insert, it's this one. NE is a new I'm trying to insert, it's this one. And now we can just copy and paste the things as they appear here. So we do this span of all of the ranges in my set S whose end value is less than my new beginning, strictly. And that gives me a span, so it gives me all the one below and then the others. Why isn't range end in scope? It's right there. Oh, because I should export range begin range end, even though I don't export the range constructor. Okay, that one is on me. So if I do that, what's happening with GHCI? And be not in scope again. Just need to redefine R again. There we go. So I can define S, define NB, and define NE. There we go, almost there. There we go. Now we can try this split there. Why is it giving me so many... Why on earth the fact that main is an ambiguous occurrence makes this thing fail? Fascinating. If I do a let, okay, if I do a let, it works. There we go. So now I have below, which is the set of ranges that are strictly below my new value. So my new value NB is 14. And in my set S of 1 to 5, 10 to 15, 20 to 25, 30 to 35, only 1 to 5 is strictly below 14 because 10 to 15 overlaps with 14. And I have, I called it remaining, which is all of the sets afterwards. So 10 to 15, 20 to 25, and 30 to 35. Then my second line splits remaining into overlap and above. So let's do that. And now I have, so again, my sets are 1, 5, 10, 15, 20, 25, 30, 35. I'm trying to insert a range from 14 to 26. Below is all of the ranges that do not overlap, so 1 to 5. Oops, sorry, that it should be visible. Above is all of the ranges that do not overlap because they are above, so 30 to 35 is the only one. And as a result, overlap will be the ranges that do overlap with the new range I'm trying to insert. So 10 to 15, 20 to 25, they both overlap because I'm trying to insert from 14 to 26. So now I compute the new beginning, which is the lowest of the values in my overlap, or pending that, the new range that I'm trying to insert. So now this overlap begin is 10, because in the overlap, I had like 10 to 15 was overlapping with 14 to 26, but 10 is less than 14, so this is going to be our new range. The end is going to be 25. Wait. Yep. This should read max. There we go. The end is going to be 26, because that's the max range that we are trying to... Why is there maybe? Because there might not be any value in the overlap. For instance, if I were trying to insert a range from, let's say, 26 to 28, actually, no, that would still be fine. If I were to try to insert a range from 26 to 28, it would have no overlap with any of the existing ranges, and therefore, overlap would be here, would contain no value. So lookup min would give me a maybe value because it could give me no range because this set is the empty set. So if that happens, I'm thinking that, oh, there's no overlap. My new minimum is this value. If there's no range in the overlap, my new maximum value is this one. But if there is one, then I apply begin and I do the minimum, or I apply end and I do the maximum. That gives me here overlap begin and overlap end. End is 26 and overlap begin is 10. Now I create a new set that only contains this range, and I combine them together. A fold min with NB the same. Probably yes. I think you might be right. Well, it depends. Fold. Well, it would need to be a monoid, right? But I could do a get. I think min is a monoid. There is a minimum. Or maybe a fold map or something like this. But I think there is a minimum and a maximum monoid. Yeah, there we go. Those exist. Wait, but they must be semigroups, not monoids, right? Oh, monoid. Huh. Oh, but it gives me the max. Yeah, which is not what I want. Okay. Yeah, it would probably be possible to do with a fold map of some kind. But this is fine, I think. And now, after this, we have the new... So we can discard all of the ranges that were in the overlap, and we can create a new range, which is this one. Like, new range set based on this. Which gives us a new set which is only contains the range 10 to 26. and I can recombine with the below and above. And if I do that, I now have range from 1 to 5, range from 10 to 26, and range from 30 to 35. We have kept I'm not sure what fold function you're using. The one named fold takes only one thing that contains a monoid value. So that this would be, so that would be a from maybe. Not a from maybe. Would that be a fold map of some kind? Let's have a look at data foldable. Because I agree, it feels like this is a thing that a fold thing could solve, but not fold itself. Although I guess I could make it with an actual like fold R or something. That's minimum. That's the default value. Oh, set fold. But that value is... oh, but instead of a lookup, you mean? You mean instead of a lookup. But no, I don't want to do that because those things operate on the set. And here I am not operating on the set. I'm operating on the minimum range within that set, which is not a set, which is a range, and the maximum value range inside that set, which is not a set, it's a range. And there, since those might be empty sets, there might not be a so those folds are on maybe, not on set. That being said, maybe there is a different fold function. Yes, but your map would transform. Ah, I see. You're doing a map. So it transforms the sets of ranges into sets of values. But you still need to do the lookup min, lookup max thing. And those might still give you a maybe. Because like if you do the map first, you obtain a set of the beginnings or a set of the end values, so set of ints, but you still need to do a lookup min and do a from maybe with the minimum. So it just changes the order of operation, but it doesn't completely solve them. Yeah, there's no particular fold thing here. But I could do a fold L or something like this, because this is indeed what it is. That's the min function. That's... well, that's... Yes, I suppose this can be rewritten as... yeah, that's the same thing. Yes, but what if there's more than one range in the set? Here, the overlap has two ranges, and we need to get the minimum one in this case and the maximum one in this case. Your fold would go over both ranges. I guess it would do minimum of all of them or maximum of all of them, I suppose, yeah. I guess that would work. I think this is fine. Because your version would basically do this. I use map of range begin on the overlap. So now I have a set of int that might be empty. And then I do a fold on the set. Using minimum and the NB value. Yeah, I agree. With the downside of you're going to apply minimum on all of the things in the set rather than doing it once on the minimum set in the thing. And well, this version does only one minimum call between the minimum thing in the set and this. And this might be better in the sense that if there is a large number of ranges in this set, getting the minimum will be a much faster operation. It's going to be log n, and then I do only one minimum, while this fold will do a minimum on all of the values of the overlap. So if the overlap were to be quite large, this would be less performant than this. But otherwise, for like small overlaps, yeah, this is basically equivalent. Okay, and now with all of this, we have created a new set that has merged, has combined all of the sets that were ranges that were overlapping, and now our set of ranges still contains disjointed ranges, but we've preserved the invariant after the insert. And now if we redo the same logic, but with a much larger value this time, let's say 40, 45. And I do... It's since sets are implemented as trees underneath, lookup min would just go traverse to the left until you reach a node, basically, and lookup max would be basically traverse to the right until you reach a leaf, and return maybe if there is no value in the set, basically. If we do, then I'm just gonna copy this as the new set. So now we have our new set like this, and I'm trying to insert this time 40 and 45. Now, below and remaining, where are you? Now below is the entire set, and remaining has nothing. So when I split remaining into overlap and above, both overlap and above are empty. So now, since overlap is empty, this is going to give us a nothing, so this maybe will give us the NB and the NE. So when we redo this, so overlap begin will be... Overlap begin will become just the new value. Likewise for overlap end. And as a result, our new set will be the exact same as before, but just with 40, 45 added. So that's the logic of this, basically. So now, what we should be able to do, we should be able to test it. So if I do a from list of, so in this case, the RS from list, that contains a range 12 to 16, and a range 3 to 8, and a range 14 to 20, and a range 1 to 7. Here we should get, so we get 1 to 7, 12 to 16, because... Oh, well, it's broken. Perfect. Fantastic. We've discovered something. 8. Oh, is it because of the max here? Did I not recompile this? I need to redefine. So R is going to be my function that does from just of range BE. Now if I do this, yes, okay, now it's fixed. I have 1 to 8 because 1 to 7, 3, 8 combine into 1 to 8. And I have 12, 20 because 12 to 16 and 14 to 20 combine into 12, 20. So now that we've spent some time doing this, we will probably need to add more stuff in this, but this is still good enough for now. We can actually do day 5. So first, we're going to need to parse the input. So our input this time is going to be input ranges, which is going to be a list of range of int. And it's going to be, what are they technically in this? They are ingredients, which is going to be a list of int. I'll align this just so it's nice. So how do we parse this? I am very tempted to use parsec there again, just because it makes everything so much easier. So this input is gonna be parse with, and we're gonna get our ranges, which is gonna be many one range. Wait, I don't remember if parsec uses the sum or the many one notation. Sum seems to be the one, and many one is not. Okay, so sum is what I want. Hello, everyone. So sum range, and then there's going to be some, well, actually, it's going to be range separated by a new line that we ignore, and then the ingredients that are going to be ingredient separated by new line, and a range that's going to conflict with my range set function. So I'm going to name it range line or ingredient line. A range line is a number followed by the symbol dash followed by a number, and we return a I can just do a from just here, I don't really care, of range beginning end. And an ingredient line is purely just number. Okay, that should be fine. So that's parsing the input. We will have to test that. And then part one will be, what are we actually trying to do? We are trying to... How many of the ingredients fall within the range? Okay, perfect. So I'm just going to copy this quickly to have an example string here as well. Oops. There we go. And I need this here. Okay. So that's our example thing. So now what we do with this, assuming this works, we haven't tested it yet. What we are going to do here, given some input that contains ranges and ingredients, we are gonna do a count true, which given a list of Boolean tells us how many of them are true, and for each ingredient in the list of ingredients, we are gonna return a Boolean, which is... Wait, do we want the ones that are within or not within? Fresh, because it falls within the range. So we want to check ingredient within range set. And the range set is going to be defined as from list of the ranges. I could make this a range set immediately, but I don't know what part 2 is, so for now, let's not do that. Okay, let's see if this works. Record syntax is illegal here because I said type and not data. There we go, let's fix this. Oh, this of course needs to return an input with the ranges and the ingredients. And now that should be everything. Not in scope from just, that's from data maybe. No instance for show input. Yes, I forgot that. Deriving show. Okay. And I'm running the wrong day. This is day 5. What on earth? What on earth are you saying? Oh, is this because I have a buffer that's still on my... Yeah, I have a buffer here that Emacs is trying to save, and I am not saving that buffer. Okay. So let's try. First, I want to check. Aha. If I do this, will it work? Here the parser is unhappy because of this one. It's trying to pass something else. Here, okay. I get that my ranges are 3, 5. Oh, that's completely wrong. That's completely wrong. Okay. So I'm using the wrong parsec thing here. I'm using sep and by. Oh, I know what's wrong. I know what's wrong. When I pass the number here, I probably end up passing, I think, my number thing, which is coming from my Advent of Code library. Probably... Oh no, it doesn't skip spaces afterwards. So no, it doesn't. Okay. Hmm. So when I do the separated by new line, oh, is it because I have messed up? What on earth? It should try to match this, then match a new line, then try to match this again, and somehow this doesn't work. Let me check that sep by is working the way I expect. Hmm. Do I have an issue whether the new line is consumed by this parser? That seems weird. Because number is coming from here. Oh no, it does lexem. It skips spaces. That's what's happening. So here, this is skipping spaces. So this becomes many range line. I remove this, and at some point it's gonna fail because it's gonna encounter a new line. Oh, except... So I should probably make it not skip spaces. That might be the easiest way to do this. So let's do this again. Separated sep end by new line. And here this is gonna be, so number is not the one I want to use, so I'm gonna have to use something else. Let's create value, and value, and the value is gonna be read of many one digit. Okay, let's try that. Now our test input contains the range 3, 5, the range 10, 14, the range 16, 20, the range 20, 12 to 18, and then does not contain ingredients. Welp! Actually, there's probably going to be a new line at the end there. So why is missing there? Why is it not passing the ingredients? Is it just missing a new line? I think that's what it is. Expecting digit. I am confused by parsec. Now I think the new line here needs to happen. Line 12. Or perhaps I need to do a separated and sep end by as well. Oh, maybe it's was failing to pass the actual input. Okay, and now we have the ingredients 1, 5, 8, 11, 17, 32. Let's actually print the real input just to check, see what shape it has. Oh, sorry, I missed your messages. This is part 1 because I spent some time doing a range set implementation, so a set of range of values in which the insert function guarantees that, like, merges sets to to guarantee that they are all disjoint. Now I'm just doing some work on passing the input. There we go. And I just want to check that, oh god, this is large. I just want to check that if I print the input ingredients of my real input, it contains the actual, like, it passed this correctly. So this should finish, yeah, it starts on the right value, I think, if I remember correctly. Yep, so that seems correct so far. And I'm just gonna print the last of that to check that I have something that's indeed at the end there. Yeah, okay, so it's working. Passing the input is working. That's always good. And now we can try part 1, which is just we create the set of the ranges and we check which ingredients are within the set of ranges, and we count the number of ingredients for which that's the case. And we get 3 for the test input, which is this thing, which I think is the value we are expecting. Okay. And we get 635 for my real input. Let's try to see if that's correct. That's correct. Perfect. Let's move on to part 2. So what do we do here? Oh. Oh. Well, with the range set, this is trivial then, isn't it? Because this is basically how many values are in each range, and my range set is guaranteed to be disjointed sets. So I just need to compute how many values there are in each range, and I have my solution, right? Well, the thing is, the having a range set is something I've been wanting to do for a while because range operations like this are very common in advent of code problems. So having it now in my library of functions for the advent of code will make this a lot easier in the future. So this is going to be. I will need to add one more thing to it. I will need to have a way to convert back into a list. So I will need to do a toList of a range set of A into a list of range of A. And toList is simply going to be for a range set, claims a set S is going to be a set toList of S. Does this need ORD actually as a constraint? I don't think it does. But let's check. It doesn't. Perfect. And the other thing that we're going to need, I'm probably going to want to do a function here. I'm going to call it cardinality, I suppose, or size. Size is very... size is fine. Which, given a range, gives me a value of the type of the range, which will require some constraints. We'll see which one, probably num at the very least. So given a range that goes from beginning to end, that is 1 plus e minus b, I think. If they are both the same value, that's 1. That's correct. If this is 1 and 2, that's... yeah, okay, I think that's correct. However, this requires at the very least num of a on the constraint, I think. Now with this, we should be able to express part 2, and I'm gonna actually change something. I'm gonna say that my input is actually a range set of int, and here when I pass the input, I will here do a range set from list of this. So now I have the range set in my input, and I don't need to do that. And part 2 becomes, given some input that has the range set and the ingredients that I no longer care about, this is going to be doing a sum of, for each range R in the list of all of the ranges. So toList of the range set, return the size, they say size or cardinality? Size of the range, which I can rewrite as being a sum of map size of toList of the range set. And that should be part 2. Define will not use size because I forgot to export it out of this module. Likewise for toList. If this works, we're expecting to find 14 for the test input, which we do, and we find this gigantic number for our actual input, and that's the right answer. That is day 5. So yeah, we spent a lot of time going over the range set, making sure that this insert thing worked as expected, and then the actual hurdle has been writing the parsec thing to actually parse the input. This was the most difficult part of today, because yeah, with a range, a set of ranges, this becomes quite trivial. Okay, and I'm done with the advent of code for today, I believe, because I don't have anything else. I was tempted to try to do more of the challenge runs I often do, which is either doing stuff in Brainfuck or doing stuff at the type level in Haskell, but neither is a good fit for today's problem. The problem being that actually, if I don't try to do the real input, I only do the test input. Doing this at the type level in Haskell is probably not that complicated. I'm kind of tempted. I'm kind of okay. Maybe I'll do that. So I will not be solving the actual advent of code problem because I'm not gonna be using my actual input. But let's redo this thing purely at the type level. So we're going to need numbers. We have a thing called 0, which is a type that doesn't have any value. That's purely a type named 0. And we have a type which is a successor of a previous number. And that's enough for numbers. We can define a few useful ones. What's the maximum value we need here? The maximum value we need here is 32, it seems, for the test input. Okay. So I'm going to copy something from day 3. No, which day was it with the type level? Day 1. I'm going to copy this from that day. Up. And I'm not going to keep all of those because beyond 32 we don't need them. So yeah, a type 0 is just 0. The type n1 is the one after 0. The type n2 is the one after n1, and so on. So those are numbers. Here's how to add two numbers. That's a type family that to the type 0 and the type y associates the type y, to a type x and a type 0 associates x, and to a type x and a type that happens to be the sucks applied to y, returns add on. This is just as a matter of optimization, because if I do it this way, where I like go through y and add to x, then I don't need to do it if x is 0, I can short circuit. So this is purely for optimization purposes. So that's our numbers. How do we do this? I suppose we can do a range which has a beginning and an end. And we are gonna want to do a type family within that takes a range value x and a range. Oh, we're gonna need booleans as well. And within, so to do within, we're gonna need to have greater than and less than. Okay, so let's do that first. Let's do greater or equal first. So is x greater or equal to y? If I have some x and 0, the answer is true. Because whether it's 0, that's true. If it's non-zero, that's also true. If I have 0 and y, since we have already matched 0 in the case of the second argument, that's false. And if I have the last case, which is I have two non-zero values, then that is greater or equal of x and y. We can do the same thing for less or equal. So if I have 0 and y, it is true. If I have x and 0, it is false. And otherwise, we continue recursively. So that's our less or equal at the type level. This is I'm gonna need a Boolean AND. So, and to be clear, there is a lot of libraries and stuff to do stuff at the type level in Haskell, including a bunch of language extensions like datakind, but I don't want to do them. I don't want to use those because it's too easy. I want to do it purely in like Haskell 99, where I only have, well, not exactly Haskell 99 because I have type families, but purely type declaration, type families, nothing else. Monadic operations at the type level with data kinds, if we start to like lift functions at the type level and everything, we can do some very funky stuff. I guess we could try to emulate some monadic-like things, but this starting to be like the big problem here is we cannot partially apply type families, so that becomes very complicated to do like a type family that takes another type family as argument, which would be the equivalent at the type level of a function that takes a function as an argument. So it becomes a bit complicated. So we want to do a Boolean and true is true, and of b1 and b2 is false. So is x within a range R? That would be so within x of I'll have a look in a minute if you don't mind. I want to finish this first. I have a value x and a range. This will be an end of greater or equal x to the beginning of the range, and less or equal of x to the end of the range. So now we have, at the type level, the ability to do checking whether a value is in a range. I'm going to copy a few things from this day there. I'm going to copy the reify. That's going to be useful, which is going to be bringing a type at like a int at the value level. Just going to remove this comment for now. I'll clean this later. I'm going to need lists because I'm going to have a list of ranges and a list of ingredients. A list is either nil or it is a cell that contains a value x and the rest of the list L, I suppose. Now, what do we need to do? So part 1 will be given a list of ranges and a list of ingredients. This is going to be a fold over the list of ingredients while keeping a tally. So part 1 of a list of ranges and a list of ingredients is going to be part 1 prime using an accumulator, which is going to be 0 at first of those two things, and part 1 prime takes the accumulator, the ranges, and the ingredients. Part 1 prime of an accumulator, ranges, and no ingredients is just the accumulator. And part 1 prime of an accumulator, ranges, and a cell that contains an ingredient and a bunch of other ingredients will be now we need to go through all of the ranges. So this is going to be part 1 prime. We continue our recursion using a new value of the accumulator. The ranges will remain the same, and we will go over the rest of the ingredients is. And this will be, I'm going to put it on a new line for readability, add of the accumulator and within any of I and the ranges. And within any is going to be something here that does the same thing as within, but on a list. So here I have a bunch of ranges, and within any of x within an empty list is false, within any of x in a list that contains a range R and some more ranges afterwards will be a within any prime of within XR and I need to provide X and RS, and within any prime we'll get a boolean that tells me if it has been found, and then the X value and the RS for the continuation. Within any prime, if the answer is true, it was found, it doesn't matter what those are, this is true. But I am expecting this to give me a 1 or 0. So I'm going to need to do a from boolean or boolean to int, or to number, I suppose, of this. So let's do that quickly. So this is a completely untyped thing, which is the fun part. I'm doing untyped stuff in Haskell by being purely at the type level. This is n1 and bool to num false is n0. There we go. So back to this. If within was true, then this returns true. And if it was false, then I have X and RS here. I can return within any X of the RS. And that should be everything for part 1. Which means we can now make a run function. And run is going to be a print of refi of what type? Well, the type part 1 of list of things. So we just need to create the list. So we're going to have our example ranges, and we're gonna have our type, which is going to be our example ingredients, which I'm gonna copy from the actual thing, so it looks like this. Oh, this is gonna be annoying to copy. Let's actually copy the raw string from this. Oops, I didn't mean to change this file. I meant to change this file. There we go. So our example range is going to be a list that contains the range 3, 5, followed by a list that contains the range 10, 14, followed by, oh, those are n, since I'm not using any extension to, so I have to put the types there, followed by a list that contains the range 16, 20, followed by a list that contains the range 12 to 18, followed by nil the end of the list, and then we close all of those parentheses. There we go. That's our example ranges. And our ingredients are going to be... I'm actually gonna copy this. This is going to be... Okay, that should be enough to try to solve part one purely at the type level by running part one of example ranges and example ranges and example ingredients. I think, yeah, it's in this order. This is never gonna work on the first try. Indeed, my insertion thing does not respect casing properly. There we go. Within... Oh, here they need ranges explicitly. Let's rename it RS for consistency. I need an extension which is undecidable instances, which is a terrifying name, but what it does is when we are trying to do type family and type classes like instance resolution, the compiler really wants to guarantee that a such will terminate, that it will never run a infinite loop trying to do like replacement of things. So it has a very strong requirement that any substitution that happens during instance resolution needs to always be shorter and shorter to guarantee that this will converge. Me saying undecidable instances is saying to the compiler, trust me, it's fine. You don't have to check that the instances are getting smaller. They might not always. It will converge. Don't worry about it. Which means if I get it wrong, I can get the compiler to do an infinite loop. Okay, this compiles. If this works first try, I'll be very happy. So here, if I import day 05 type level, I need to restart stack GHCI. Actually, I'm not going to do it in this one. I'm going to do it in this one on the full screen. There we go. And with a stack GHCI. Do I have run in scope? I do have run. If I run, I get 3, which I believe was the expected value. There we go. That's day 5, part 1 in purely the type level. And first try, I might add, which I'm happy about. If we change, if we add, for instance, one more thing here, and we add a 17, that's already there, a 16, I should expect 4 out of this. Okay. And if instead of 16, I add another thing that's too small, like 2, I should expect to still have a 3. Okay, so that seems to be working. On the test input, I haven't tried on the actual input because generating this type level list of values from the real input would be monstrous. And also, since I'm not using any extension, trying to represent like 8-digit numbers using, well, you know, that many types, that would not work very well. Already trying to like do like a 4-digit number purely as being a type of a type of a type of a type of a type 2000 times makes GHC very unhappy. So I'm not gonna try to do the actual part 1 with this, but that with the actual input with this. But for the test input, this logic works. For part 2, can we do part 2? This would require doing merges of things. Like, do I really want to try to make type level sets, basically, using, again, not any of the extensions of the language? It would not be monstrously complicated. I can give it a try. Because I already have lists. So if I use lists as sets, then what do I need? I need a type family, which is going to be set member, that given X and a set S will tell me whether a value is within a set, which will be set member of X in an empty list is false. Set member, I will need equal, that I don't have. Oh, can I just do equal with... Can I just do equal by saying set member of X of a list in which this is the same value there? I'm not sure that's valid syntax. We'll try. And if it's not the same value, then this will be set member of X in S. Let's try this on its own. If I do a reify of set member n2 in the list that is const n2 nil. Ah, of course. How can I remove... this is very annoying. So I'm going to do an import day 05 type level as t. And so this is the one here, the one here, the one here, and the one here. Ah, of course. This gives me a Boolean, but it tells me true, actually, which is good enough. So okay, let's try again. So here I will want to use Boolean to num of that, because that has a reify instance. So when this is that, I get 1. But when I do 3 here, something is wrong. No instance 4. So maybe... Oh, wait, const. That's incorrect. There we go. Okay, and then that works. So now we can use a list as a set. We can check whether a value is within a set. Now we can do insert of a set by doing set insert of X in a empty list is just that value, a list that contains that value. Set insert of X if the list already contains the value that is just that set unchanged. And if I try to insert X in a set in which I have a different value, then this is putting this I value at the beginning of set insert of x in S. There we go. So now we have checking a value is in a set, putting a value in a set. What else do we need? We're gonna need to do type family set count, which is gonna give us how many values are within a type level set. Set count of nil is 0. Set count of a cell that contains some value I don't care about and the rest of the set is 1 plus the set count of S. And we need one last thing, which is gonna be add range to set. Oh, I'm gonna probably want to do that in 2 operations. I'm probably gonna want to do an enumerate first that, given some range, will give me a list of integers that are in the range. So enumerate of a range in which I have the same value twice is just a list of that value. And if I enumerate of a range that has 2 different values, then it is putting that first value at the beginning of a list, which is obtained by doing an enumeration of the range with the successor of B and E. Okay. Now I can obtain for a range a list of values, and I guess I just need to do a set insert all that, given a bunch of values and a set, will create a set by inserting all of them. So set insert all, if I am done, is just the set insert all of a value x within and the rest of the values in a set is going to be, continuing the recursion with another set insert all. The list of values to insert will become xs, but this will become the new set obtained by doing set insert of x in S. There we go. And with that, I think we have everything we need to do part 2. So part 2 is going to be, we only need the ranges, and this is going to be a fold over the ranges. Oh, yeah, no, I need to do something to give the accumulator. So part 2 of the ranges is going to be part 2 prime, and I give my accumulator, which is going to be an empty set of a list of ranges, and part 2 prime of a set of values and a bunch of ranges is, if I have a set S of values and no longer any range to go through, then the answer is set count of S. Otherwise, if I have a set and a range at the beginning of a list of ranges, this will be going recursively over part 2 with a new set on the rest of the ranges, and this will be the result of doing a set insert all of something into this set, and this something will be enumerate of R. Okay? So if this works, we could try to do part 2 of the example ranges. It compiles. I am worried. First try? I didn't expect it to work first try. We get 14. So yeah, that is purely type level Haskell for part 1 and part 2 of day 5. I really didn't expect this to work first try. But yeah, of course, the problem here is since I am not using any language extension, I'm not using numbers at the type level. I could do that with datakind and other language extensions, which means since I am limited to those actual type numbers like piano numbers, solving the actual real input with like 6-digit numbers would be basically impossible using this method. So I would need to rewrite this to use actual ints at the type level, which is possible with extensions. But I wanted to try to do it purely with like only types, not a single thing here that is a value. The only value we have here is here reify, which is a class that to a type associates an int, and to the type 0 associates the int 0, and to a type that there is a sucks of a number is just that 1 plus 1 basically. So that's the only value level stuff we have. Everything else is just mapping types recursively. Okay, that was day 5, both normally and not very normally. And I think that's gonna be all for today, unless I want to try doing things in Brainfuck, but I don't feel like doing things in Brainfuck. Partly because a lot of those inputs, like a lot of those values, do not fit into a 32-bit int, which means if I want to deal with the actual values, I'm gonna need first to re-implement 64-bit support for like addition, multiplication, and so on in Brainfuck. I don't want to do that, so I'm not gonna bother. I think I've done day 1 in Brainfuck because the values were small enough, but yeah, I don't want to bother re-implementing in 64s in Brainfuck, so I'm not gonna do that today. Which means that is it for today's Advent of Code section of the stream. And it is time to move back to my other project, the one I've been working on the rest of the year. It's time to go back to the compiler. Oops, this needs to be scrolled back a bit. Oh, it's a small one. It should be the big one. There we go. I have made one change off stream to the compiler. Oh, sorry, yes. Let me have a look at your code. Let me scroll back to find the link. And this was part 2. So I have it open on a different computer altogether, so I can't stream the code I'm looking at. But since you posted the link in the chat, anyone can have a look. Okay. I was gonna go. Do I go for like the big picture stuff or for the low level stuff? A very quick thing in the parse function, which is not the most important thing. A big downside of read is if the string is invalid, you will not get an error like a maybe that you can handle. You will get purely like a panic, which I think in this case is fine, but that's something to be aware of. But let's have a look. So you have a list of pair of ints and you're merging them into a list of pair of ints. So doing the same logic of the sets I was doing, but using a list instead of a set. I'm gonna assume that you are assuming that it is sorted in order. So you're doing a fold over. So you're sorting first. Okay, so you're not making the assumption. You're sorting first always. Okay. Okay, so you don't need your sort by. Let me open the GHCI here. Because sort by, you provide a comparison function, but here what you're saying is compare on the first value of a tuple. But tuples already have comparison, so if you do 4, 2 is less than 4, 3, you get true. Ignore all of those errors. Let me do this in the GHCI that doesn't have all of my stuff. You get true, and if you do less than 4, 2, you get false. So you will get basically an even better sort by just using the regular sort. Import data.list qualified as L. You will get a better sort on your tuples by using this built-in sort rather than using the sort by and giving the comparison. So you can remove the sort by and just put a sort back in its place. And that will basically do the same thing. And then you fold. So the base case of your recursion is indeed. Oh, it's not the base case. Okay, so your accumulator. If your accumulator is empty, then you just add the new range to the accumulator. Okay. Then so I'm reading line 12 to 14. So your accumulator contains one range. You have sorted them. You have that information already. One sec, I need to think. It's a fold L, so you're going through. Oh, you're not inserting a new one, you're just merging them pairwise. I see. So you have. And since you're inserting them at the beginning of your accumulator will always be the latest range that was inserted, and therefore the one with the biggest begin value in your accumulator so far. Which means if they overlap, then you merge them. Yeah, that makes sense. Otherwise, if they don't overlap, you combine them. Yeah, okay. No, that seems pretty good to me. I think like this looks pretty good. The thing I would point out are using a list means that you will, when you do like check for memberships, actually you don't care about checking for memberships that much, I suppose. So it's not that bad. It's honestly pretty efficient, I think. Yeah, I would replace the sort by a sort, which really does the same thing. You could consider changing your accumulator to always have. No, it's gonna be more. It's gonna be more complicated. It's not worth it. No, honestly, I think that's pretty good. Because in terms of complexity, you have an n log n sort, and then you just have one more n just iterating throughout the thing pairwise. No, that is honestly pretty good. So yeah, I think my only comments would be removing the sort by into like and making into a sort, and otherwise I think that's pretty good. I don't have a lot of other comments to say. Which means, again, I'm going to move back from the advent of code now that day 5 is done, and I'm going to move back to the compiler project.